Hello, this is a short post on the importance of being able to see both positive and negative amplitudes. And part of that, I'm going to talk about why it's been up to now theoretically impossible for us to do that. So to put things into context, I'm looking at this line here. I'll zoom out here so you can take a look at it. And it is part of the UK North Sea Transition Authority's Mid-North Sea High project. And the area I was looking at is right here in the middle. In here, this is the line we're looking at, yellow. And right in through here, there is an area of low amplitude, low frequency, low amplitude, which you can see here. This is a stratoscape display, by the way. Most of you will be familiar with it by now, but for those of you who aren't, what you're looking at are seismic amplitudes turned into a three-dimensional surface. So what I'm doing is I'm trying to figure out why in these zones the amplitudes, well, I'm not really sure what you'd say about them, they disappear and the frequency content just drops to almost nothing. And I'm trying to figure out what is causing it. And in this mode, there really doesn't seem to be anything peculiar happening because I'm looking only at positive amplitudes. I'm looking at the positive impedance events. This event up here is the water bottom. So let's see what happens when we use our dual polarity display. Boom. So this is the dual polarity display, and as you can see here, the green events here is negative impedance. White is positive impedance. So when you're looking at it like this, the problem becomes really obvious that we've got this huge low impedance zone right below the water bottom. But if we were just looking at a single polarity, you wouldn't notice it. So let me show you why it's been up to this point almost theoretically impossible for us to be able to perceive positive and negative amplitudes with equal strength. So to do that, let me turn this into something you're more familiar with, which is probably this, which is a variable density display. Actually, I'll turn it into a standard red, blue variable density display, and I'll save that scene. Okay, so red here is positive amplitude and blue is negative amplitude. And this display, incidentally, dates back to 1979. And the reason we use red and blue is because they are visually distinct. We didn't know a lot about the visual system in those days, but I'll just show you why you can't get equal perceptions of positive and negative amplitudes here at the same time using this type of color palette. So I'll just show you the color palette here. Blue on one side, red on the other. And we're using equal shades on either side. So both sides start out white in the middle, go to pure red here, pure blue here, and then dark blue, dark red. So it's exactly the same color shades, but you'll notice here that we get far more detail out of the red than we do out of the blue. That's because our visual system is tuned to see differences in colors at the red-green end of the spectrum. When you get to the blue end of the spectrum, we have very poor color perception, and our ability to discriminate colors at that area is very low. And that's why, as you're looking at this, and let's just look at a few other places here, right? Looking through here, for example, we see more gradations in red than we do in the blue. And I'll just reverse the polarity here. Foreground, reverse polarity. And you see now we get more details in the negative, which is now red, and we've lost them in the positive, which is now blue. So this is, in theory, it is impossible using this type of color display to get equal perceptions of positive and negative impedance. And that really hurts us up here because, you know, if we were looking at this, this probably wouldn't stand out as anything really alarming if we zoom out here. It's one of the reasons why we have to use stratoscape displays, because as I'll show you here, as soon as we do this, now we get complete amplitude perception. So these are amplitudes in 3D, and I'm interpreting this as being either gas hydrates or some low velocity glacial crud. This is a glacial scouring through here. So it's quite possible this is just gravel, water-soaked gravel beneath the water bottom. It could also be gas hydrates. But in any event, if I were drilling a well through here, I would want to know exactly what's happening here to the amplitudes immediately below the water bottom, as opposed to looking at this. I think this is just better. That's enough. That's all I'm going to say. Bye.